Hi, everybody. So, tonight I'm going to cover section 2.2 with you guys virtually via video. So, you guys can pause, pause, and we will review the next time we see each other. Okay. So, what do I have for objective tonight? They're very brief. How to graph and interpret quantitative data using stem and leaf plots. So, what a stem and leaf plot looks like. I'm not going to cover dot plots because they're not a really big importance in statistics and we rarely use them. How to graph and interpret qualitative data using pie charts and Pareto charts, and how to graph and interpret pair data sets using scatter plot and time series chart. So what does a stem and leaf plot look like? Here is a stem and leaf plot to the right here. So this is where each number is separated into a stem and a leaf. So you have the stem here, and then you have the leaf on this side. The way I will read the data is, for example, here you have 21, 25, 25 again, 26, 27, 28, 30, 36, 36, and 45. And it is sorted already for you. It has the shape of a histogram because, look, if you place bars right here, then this is what you're going to see. All right. If you flip it, okay, if you flip this guy, that's exactly what you're going to see. Let me see if I can try to flip it. See, you get a histogram. You guys see that? So it has the shape of a histogram. Look, and now we can comment on the shape as well. This is skewed to the right since the tail is on the right. Okay, so there goes a stem and leaf plot for you. If I don't have a lot of data, for example, here, my n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's even. Then for me to get my median is somewhere right there in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my median is going to be 27 plus 28 divided by 2. Then I'm going to get my median from there. All right, you can quickly also get your Q1 and your Q2 and your Q3, etc. from there as well. You can quickly get that there. So my median here is going to be 27 plus 28 divided by 2. So let me quickly do that. Using my calculator. So my median is going to be 27.5. All right, my Q1, we already know Q1 has to be right here in the middle. So what's the middle for me here? 25. Q3 has to be also somewhere here in the middle. What's the middle? 36. Yes. What is my minimum? You can quickly see the minimum, 21. The maximum is 45. So you can quickly get your 5-number summary from here just by looking at your stem and leaf plot. All right, so it's similar to histogram, still contains original data values, right? From the stem and leaf plot, if your data is not much, you can comment on it, comment on the shape of the data. You can comment on even the shape of your histogram. You can quickly figure out what's the minimum, what's the maximum. You can quickly get your Q1, Q2, and your median, your 5-number summary. All right, let's take an example here. It says construct a stem and leaf plot. You've been given the numbers of text messages sent last month by the cellular phone users on one floor of a college dorm. It says display the data in a stem and leaf plot. The first thing you will do is do stat edit and enter that data into L1. Okay. Once you have the data into L1, then we will sort the data. And once we sort the data, then we can start getting our stem and leaf plot. And notice they told you 78 should be 78. 159 should be 59. So this should be the stem, and this should be the leaf. Stem and leaf. Stem and leaf. And we ought to be able to comment on the shape of the data. Okay? So Mia already placed my data in. So I'm going to show you. I already have my data in L1. Here goes the data. For me to sort it, remember you got to go to second function quick. Okay, you want to sort it, you go to start and sort ascending, you press enter, and second function, and you select your L1 right here. Close parenthesis, press enter, it's going to say done. Then you can go back to start, edit, and here goes your data. It's been sorted for you. That's all you wanted. You wanted the data to be sorted. If you go to second quest, and of course, you do second function, and you select L1, press enter, there goes your data as well. Okay, so we're going to use that, all right, to just graph our stem and leaf plot really quickly. Okay, so I'm going to have 78, of course, and then you jump to 105. But before you get to 105, you got to go to 80 to 90, and then you get to 105. There goes 105, and then 8, and then 9, and then 112. Are we all on the same page? This is how you place your data in the stem and leaf plot. Then 116, then 118 twice, then 121, and then you have 22 two times, and then 3, and then 26 multiple times, 4 times, and then 29 2 times, and then you get to 133, 39, 9, and then 140, 44, 45, 45 is twice, and then 7, and then 8, and then 155, 59, and that's it. So here goes your stem and leaf plot. Look at your histogram. There goes your stem and leaf plot. There goes your histogram as well. Here we go. It's pretty kind of symmetric in a way. Yes. So this is an ordered stem and leaf plot. It's kind of symmetric, right, from the display. Okay. If you go to Stat Calc L1, mine wasn't in, yeah, it was in L1. Stat Calc L1. Stat Calc 1 var stat L1. All right, you're going to get the summary statistic really quickly as well. So this is what we get for the summary statistic. So what did I say? Stat, calc, 1 var stat, plug in L1 here. So you do second function. Your L1 is right here. And you press calculate. You're going to get your summary statistic. Okay. All of it. All right. You're going to get your summary statistic. From the summary statistic, we get the 5-number summary. So my minimum here, of course, we can see the 78. Your maximum is 159. And then we know Q1 is 118. I see it here. Your Q2 is the median. It's 126. Your Q3 is 142. All right, there goes your 5-number summary. Now, an interpretation of it, there are many interpretations as long as they align with your data, with your findings. So from the display, right, we can conclude that cellular phone users in this dorm sent at most. If I'm talking about at most, I'm talking about the mode. Here goes the mode, 126. At most 126 text messages in a month. You can talk about anything. You could talk about the median. You could say 50%, right? Sent less or 126 text messages in a month. So 50%, remember, if this is the median, 50% is on the left, 50% is on the right. So if your median is 126, I'm saying that 50% or less sent 126 text messages in a month. Your interpretation, my interpretation, as long as it's aligned with the data, it's fine. Yours could be different than mine. I'm not talking about dot plots. Y'all can read about it. Read on your own. Not talking about it. Read on your own. All right, let's talk about graphing qualitative data sets. If I have qualitative data, the graph of choice is a pie chart or Pareto chart. Let's start with the pie chart. It's a circle divided into sectors that represent your categories in the data. The area of each sector is proportional to the frequency of each category. I'll tell you how they get this area here. So here it says the numbers of earned degrees conferred in 2007 are shown in the table here. Use a pie chart to organize the data. So they gave you type of degrees: associates, bachelor's, master's, first professional, and a doctoral. And then they gave you the numbers in thousands, right? Numbers in thousands. What does that mean? For example, here it says that 728,000, right? Degree earned or degree conferred in 2007 were associate's degrees. That's what it means. So this is basically my frequency right here. There goes the frequency given to me. It's a count of the number of degrees conferred in that year. Remember, you can find the sum of your frequency. Yes. Now, relative frequency, this is where you do 728 divided by that sum. All right. So the first thing I'm going to do, I'm going to put this data in. I'm going to put that data into stat edit. I'm going to put it in L2. All right. So that's where I'm going to start by putting my data. I'm going to put that one in L2. And then I'll find the sum of L2 to make my life easy. So here goes the data in L2. 728, 15, 25, 604, 90, 60. So this is where I'm going to put my data in. And then the next thing I'm going to do, I'm going to find the sum of that. The sum of it. So the next thing I'm going to do, I'm going to find the sum. For me to find the sum of this guy, I do second quiz. And I believe I showed you last time the sum was under second function list. If you go to math, then sum there. Second function, the sum of L2, I believe, close parenthesis, press enter. So 3007. There we go. There goes the sum. There goes the sum. Where do I put it? Right here. So this guy is going to be 3007. Now I want to build the relative frequency. Remember, if you sum all relative frequency, you should get back 1. Those are your percentages, yes? So for me to get that, I'm going to divide each frequency by 3007. Or I can build another list where this guy is going to be L2 divided by 2007. It's very easy. I can just build that list. Okay, so let me go ahead and build that list. So going back to stat edit. So L2 is already taken. Let's go to L6. I'm going to make it second function. Or you could just come here and say you want L2 to be divided by second function L2 divided by what? 3007. You can just do that. Here we go. Okay? We can just do it this way. So we don't have to put in a list if we don't want to. And you just use the arrow to move it. Okay, so there it goes. 728. So this is going to be 0.24. The next one is going to be 0.51. I'm rounding to the nearest 100. 0.20. 0.03. 0.02. When you add all of this, you should get back 1. For me to get the central angle, remember the sum of all angles in a circle is equal to 360 degrees. So if I want the degree of each central angle, I do 360 times 0.24, 360 times 0.51, 360 times 0.20, 360 times 0.03, 360 times 0.02. All right, once you do that, you're going to get 86 degrees, 184 degrees, 72 degrees, 11 degrees, and 7 degrees. Yes, so what does that mean? There are many interpretations to this. Okay, many interpretations to this. But what can I say? From the pie chart, this is just one of my interpretation. From the pie chart, we can see that half of the degree conferred in 2007 were bachelor's degrees. Half, is 0.51. We can see that slightly more than half of the degrees conferred. Here, this is 2011. So let me put 11 here. Half of the degree conferred in 2011 were bachelor degrees. That's my interpretation. You could say more. So much more you could talk about. But there goes a pie chart. Okay? And we can all get all of that in SPSS. We'll talk about it. Let's talk about Pareto chart, shall we? The Pareto chart is a vertical bar graph, but notice there's space. Vertical bar graph in which the height of each bar represents frequency or relative frequency. The bars are positioned in order of decreasing height with the tallest bar positioned at the left. So here, for example, it says in a recent year, the retail industry lost $36.5 billion in inventory shrinkage. Inventory shrinkage, what is that? Is the loss of inventory through breakage, pilferage, shoplifting, and so on. The causes of the inventory shrinkage are administrative error, employee theft, shoplifting, and vendor fraud. It says use a Pareto chart to organize this data. So here goes your frequency table. Okay. So here, for example, it says that employee shoplifting, right? Shoplifting, because of shoplifting, the company or the retail industry lost about $12.7 billion. That's a lot of money. All right, when you put your Pareto chart together, this is what you see right here. So this guy was 15.6 billion. This guy was 12.7 billion. This one was 5.4 billion. And here vendor fraud, 1.4 billion. And of course the rest is unknown. But from the Pareto chart, one can conclude that the highest cause of inventory shrinkage is what? It's not shoplifting, is employee theft. So that's what they should be addressing first before starting looking at people as if we steal their things. So this is a Pareto chart. Okay, when we meet on Tuesday, it's really for me to show you how to get all of these things in SPSS. I might just send you a video just before. Let's talk about paired data sets. So here goes paired data sets. Each entry in one data set corresponds to one entry in a second data set. So to represent a paired data set, we use what we call a scatter plot. You've probably seen something like this before. These are ordered pairs. They are graphed as points in a coordinate plane. They are used to show relationship between what? Quantitative data. Relationship. You want to show relationship between two quantitative data. Now, this should look a bit familiar to you guys. Whenever you covered linear regression in one of your math class or maybe in high school, you looked at a scatter plot. Now, let me go back to the concept of slope. Now, there are multiple types of slope, correct? You could have no slope, that is your m is equal to 0. You could have a positive slope. It means that your m is positive. You could have a negative slope. It means that your m is negative. And you could have an undefined slope. We'll talk about it. So what are some of the examples? Okay, let's talk about that. If we say we have no slope, then what does the scatter plot looks like? Remember what your x is. Your x is an independent variable. Your y is a dependent variable. Meaning what? Your y depends on x. Imagine I'm talking about the amount of snowfall, right, as the hour passes by in a winter storm. I'm going to say that again. Imagine I'm talking about the amount of snowfall as time passes during a winter storm. Imagine I'm talking about the amount of snowfall as time passes during a winter storm. What's going to be my independent variable? What's going to be my dependent variable? Remember, I'm talking about time and amount of snowfall. Time is going to be independent because that doesn't depend on anything. The time passes by. But what does the amount of snowfall does? It increases. We are in a winter storm. So your dependent variable will be here, amount of snowfall. I hope you guys now understand what it means to be dependent or independent variable. If I have no slope or no relationship between time and amount of snowfall, this is the pattern you should see. Something like this, where you can just draw a line throughout. No slope. Now, if I have an increasing relationship, that is if as time fly by, right, as time goes up or as time increases, the amount of snowfall increases as well, then this is the relationship you're going to see, an increasing behavior. It looks like this. So you can just put a line right here, go straight up, increasing, or my slope is positive. Now, let's talk about when the slope is negative. Imagine that we still have the amount of snowfall, but we are no longer in a winter storm. We are no longer in a winter storm. So what's going to happen as time increases? You're going to have a decreasing relationship just like this, like so. As times goes up, your y goes down. Decreasing. This is where your slope is negative. Decreasing behavior. And finally, when I talk about undefined slope, is when in fact this is what you see. There goes the relationship. This is undefined. Okay, so I wanted to quickly review that. You should have seen this sometime in algebra 2, somewhere in high school. Now, let's interpret a scatter plot. This is a very famous data set called the Fisher's Iris data set. This data set describes various physical characteristics such as petal length, petal width for 3 species of iris. The petal length form the first data set, the petal width form the second data set. And this is what it looks like. See that? Do you guys realize what type of relationship exists between petal length and petal width? Can somebody think about it and say it out loud? What type of relationship exists between petal length and petal width? It says each point in the scatter plot represents the petal length and petal width of one flower. So what's the relationship? If this guy is X and this guy is Y, as X goes what? Y goes what? As X goes up, what does Y do? Y is also going up. So this is an increasing relationship. Your slope is definitely positive. So as the petal length increases, the petal width tends to increase as well. So what it means from the graph is that it appears that there exists a positive linear relationship between petal length and petal width. That is all. There exists a positive linear relationship between petal length and petal width increase. So that's what you have here. That's what we have here. So let's talk about time series. So we talked about so far stem and leaf plot, right? Pie charts, Pareto charts, yes? Now stem and leaf plot, you use that type of plot for quantitative data. For qualitative data, you can use a pie chart, you can use a Pareto chart. For quantitative data, you can also use a scatter plot as long as you have pair quantitative data set. Now, the last one I want to cover tonight is called time series. Time series, it's literally another type of scatter plot, right? But now we are going to join those points with a line. And we're using quantitative data, and the x-axis is always time. This is why we call it time series. So the data set is composed of quantitative data entries taken at regular interval over a period of time. For example, amount of snowfall, right? As time goes by during a winter storm. Another example would be the amount of precipitation measured each day for 1 month. So we use a time series chart to graph that. Here, for example, you have a table that lists the number of cellular telephone subscribers from the years of 1998 all the way to 2008. It says construct a time series for the number of cellular subscribers. So here we go. So we have here, and we have the number of subscribers. Now, they added also the average bill, but we are not interested. Not that it's of no interest, but in this exercise, they're not asking you to use it. We're gonna let the horizontal axis represent the years, Vertical axis represent the number of subscribers. It says plot the paired data and connect them with line segments. So here it is. This is what it looks like. Yes. We're going to do the same thing with our calculator. So go grab your calculator. We're going to do the same thing as well. We're going to put this guy. I'm going to show you where I put that data. But we're going to go to Stat, Edit. Okay. Remember, I'm using my full data over here, but you can put them wherever you want. I put my years in L3, and I put my subscribers in L4. That's what I did. So let me take a picture of that. Okay. 1, 2, 3, 4, 5, 6, 7, 8. I made a mistake here. 1, 2, 3, 4, 5. I made a mistake. I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. 1, 2, 3, 4, 5, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. I'm trying to figure out where I made a mistake, because it's so easy. 69.2, 86, 109, 128, 140, 158, 182, 207, 233, 255, 27. All right, so at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11. Normally, I shouldn't have any issue, but I have stuff that don't add up properly. Okay, now let's take another picture. This should work now. Here we go. So there goes the data. Right there. So now, once I have the data in, notice I called here 1998 1, 1999 2, 3, 2003, etc. That's what I'm doing. Now I'm going to go plot this guy. We're going to do second function stat plot. We're going to go turn that guy on. All right. The type of graph, we're going to take choice number 2. Type number 2. And then we have L3 for X, L4 for Y. Now remember, we're going to go to window fixing. All right, I'm going to leave it as it is. This guy go from 0 to 12 in increments of 1. Okay. Let me go see what's going on. L3, L4. All right. Let me make sure that I don't have anything else on. Nope, that's it. Let me go to Zoom Stat. Here we go. Okay, so I'll show you how I got that. I will show you how I got it. So me show you how I got it. So this is your calculator, yes? You want to start edit and you entered all your data. My data is in L3 and L4. Remember where your data is. Then you do second function start plot. You're going to turn this guy on, the first one. So you select on here, you select this guy, L3, L4. That's what you have to do. Once you select that, you go to zoom and you select zoom start. Once you select that, you go to zoom and you select zoom start. And here you go, as simple as that. Now that you have your data in, you have your graph, now it's time for interpretation. See, this is an increasing behavior. So the number of subscribers have been forever increasing since 1998, with a greater increase that happens here and here. Right? The number of subscribers has been steadily increasing since 1998, with a greater increase recently. You can talk about between the year 2005, 2006, 2001, 2002. And 2001, 2002. Because this is where your slope is a bit steeper. That's the end for today. So after watching this video, refer back to your Google Classroom for further instruction, especially about homework, assignments, and what to expect next meeting dates. All right, enjoy the rest of your evening. Good night, everybody.